Oh, okay. Hello and welcome to this session. We're excited to have you at the session today. And this is perhaps our fifth session on the practical machine learning course. So I'm just going to go over today's agenda, what you learn real quick. You get to know the host for the program and how you can join communities going forward and propelling your career and introducing the speaker so you go quickly into the session. So why are you here today? Of course, you're here to learn from Stephen Gabriel, who is, of course, an NLP engineer, a data engineer who has had a lot of industry experience, and he's going to be talking about machine learning operations. So we try to make sure that our sessions are tailored for beginners, and that's why we explicitly have tailored advices rather, and tips for beginners. And one of those tips, of course, is that beginners really, if you're a beginner in this watching this session, you should be able to make sure that you take note of terms you don't understand. So there are going to be a lot of ambiguous terms that are going to be used, and of course the speaker will try to make sure that things are broken down as much as they can. But terms you don't understand are things that you should really take note of. And of course, after the session, you go research on those terms, engage with the community on social media, on Twitter, tag experts, ask them questions. You're most likely going to get responses as well as other members. The AI community is a very friendly community online and networked community online. So take home and this is not just for beginners, but for the broad spectrum of practitioners, beginners, everyone. Take home best practices and good methodologies, because those are the key things that really help you grow your career. So take home best practices and good methodologies as much as you can from the session. So of course, what you learn. So you're going to be learning why you should consider ML operations, what it is, why you should consider it, how it fits into the entire machine learning pipeline, machine learning workflow, and how it differs from DevOps, and the skills you need to learn, the MLOps, and of course the necessary tools to learn for doing effective machine learning operations, as well as how you can why a consistent practice of putting your project into production, no matter how small it is, of course, no matter how small it is, will help your career a lot. So before we go on, get to know us as the host. So we are Port Harcourt School of AI, and of course you can find us on our website, phschoolofai.org. We released a report last year for why we do this, and we are very active on Twitter at PHC School of AI, so you can check us out. And of course, we're a non-profit organization whose mission really is to build a competent and collaborative AI data learning community that can be able to solve problems. So we are currently situated in River State, and we try to make sure that our core philosophy of making River State data driven is something that we also tend towards as well. On whether it's a small scale or a large scale, depending on how we go about it. So what we do, we try to make sure that AI and data education are kind of inclusive, are very inclusive, following the Sustainable Development Goal 4, SDG 4, and trying to make sure that these education are democratized and accessible. World-class AI and data education are democratized and accessible. That's why we try to gather experts, whether it's industry practitioners or researchers or academics, and see how we can make sure that they share knowledge freely. And that's the world-class education we'll try to see. Engage the community, mentor them in ways that are not hard to come by. Yeah. So our story so far, we have our reports, so you can check out our Twitter page. We share a lot of things we do, and our report as well from last year. So philosophy behind our programs, we try to make sure that after every program we hold, specifically for members, we make sure that they emerge as leaders and as well as empathetic problem solvers. So leaders meaning they are responsible for their growth, which is their competency, as well as the growth of others, which is their collaborativeness, as well as being empathetic problem solvers, looking to solve problems and take on challenges and make sure that they are not left behind in the world of excellent problem solvers. Yeah, but this session today is all about you, and we believe that successful communities are those that really put their members first in every plan. And where you should go from here, after the session, we expect that you join an AI learning community in your region. You explore more on the topic for today's session by clicking the links. So we have the slides and links below. We also have books that you can get on Amazon, which is also a great way to tell you that we are Amazon affiliates for certain books of some of the experts we bring here, and they are not sponsored. These are not we are not trying to promote them, so it's very optional. But when you try to purchase these books, you support the efforts of our community and making sure that we keep on bringing about world-class AI education. So you can check the links below in the description for the books that you can get there. Then get started. If you've not started machine learning and you're watching this, get started. If you've started already, keep on going. If it's something that you really want to make a career, that's the best thing you can do. You can keep on going, keep on learning, and making sure that you are up to date and so on. So of course, ask questions on Twitter. Twitter is my favorite social media networking site for a very large community like the general AI community. So Twitter experts. You're this time having an argument with the head of Facebook AI, head of AI at Facebook, and next time you're reaching out to Elon Musk and is replying, of course, not fiction, or Jan LeCun, or all of these pioneers in the AI space, and you're having casual and comprehensive conversations with them. It's really an amazing feeling, and you can always tweet to experts, and not just experts. Generally push out your questions, tag communities, and make sure that you're out there. You're making sure that you're interacting with people. That's the best way you can really connect with the community. One of the best ways, as for online, of course. So, but yeah, there are lots. Before I go on, I think there are lots of communities, and we are currently in Nigeria. So there are lots of AI communities in Nigeria, and of course, the leading AI community, not just in Nigeria, but arguably, the whole of not arguably, to be frank, the whole of Africa. Of course, data science Nigeria is a top community in Nigeria. You can always enroll to join, as well as other local based communities like AI Saturdays, and of course, Port Harcourt's School of AI. You can decide to and join us here, and you can join us through the Slack link, which is going to be active soon, hopefully this month. That's what we're planning, to make sure that we're moving all our processes to Slack so that we can accommodate larger community. And of course, on Twitter, you can follow us. And of course, if you follow us on Twitter, you're most likely going to get recommended other great people to follow in the Twitter algorithm. So without further ado, I think let's know this facilitator session. So this facilitator session is Stephen Gabriel. He's an NLP engineer at MOBicure, as well as he also has a lot of industry experience with data engineering and operationalizing ML systems and building conversational AI conversational systems and so on. So you can he's going to be talking about introduction to ML operations, like I said earlier. And of course, he has lots of experience. You can check him out on LinkedIn. Stephen Gabriel, connect with him. He has lots of experience in data engineering and building scalable machine learning pipelines and so on. So without further ado, I think I'll pass on. I'll make sure that Stephen has a session, and you can enjoy your happy learning. Yeah. I just want to position your cam clearly, so it's running. Okay, awesome. You can keep up.
Okay. So great. Hi everyone, and this is the kind of conversation I would have loved to have in person, because I really literally looked forward to coming to Port Harcourt to, talk about this, right? But apparently that isn't possible because of the whole coronavirus. So I'm painfully doing this from my own isolation, or would I say, the whole stay-at-home party. I think that's what my friends call it now. So but today we try to make as much as possible use of it and see how it goes. So basically, I'm going to be talking about machine learning operations, right? MLOps. I'm sure that there's not so much competition around it now, because it's kind of things that people don't talk so much about. It's not something that you want to think about as a budding data scientist. You leave that to the DevOps engineer. So, bit of introduction. I'm Stephen Gabriel. You can find me anywhere on the internet with us at CyberDroidman, and this is a this is kind of like a basic introduction for beginners, you know, for them to understand machine learning operations, right? Yeah, so let's go. So ops, what are they and why are they important? You know, before I move on to the next one, what exactly are ops, right? You know, whenever people say DevOps, GitOps, CubeOps, MLOps, you know, you're gonna probably see another one, maybe when quantum computers come out or anything, or cryptocurrency or Bitcoin, you see BitOps. So what exactly are the ops? You know, ops basically are focused on trying to make life a whole lot easy for people because you know, they are apparently one of the core fundamentals of agile development. What I mean by that is sometimes, you know, putting things in production is a whole lot of work because you don't, there are like lots of things that can go wrong. So you find out that developers, data scientists don't want to worry about how to put things in production or how to make it operational. So operational does not mean that your code works. There's a difference from being operational and that it's working. So operational is talking about how does this work for the end user. The end user can be a consumer at home using what you built, or another company, or an end user can also be someone else in your company. Yeah, so that is what ops. So ops kind of like come in and be like, you know what? Let's take care of the operations, right? You build your stuff and we make it operational. I mean, it takes like shit ton of headache away from a developer because they start with, oh, now I can work on my stuff. But it's not always like that in the industry because I can tell you that you might be the only data scientist in your company, and it is very important that you understand the tools of the trade before ops. Let's talk about this. So it's your first month as an entry-level ML engineer, and you just started rocking your job. Jupyter Notebooks, Scikit-learn, TensorFlow, Pandas, you know, any cool stuff or tool that you use, insert it there. Then it's time to put the model to production. Stretch face. Okay, let's go to production, lads. Look at the lads. Everybody goes away. You know, people start hiding. You know, people start disappearing. Nobody wants to be the one to put it to production. I mean, this is a very common thing because apparently nobody wants to be in charge of operationalization stuff, right? People are comfortable with when the thing works, you know, but when you want to plug it on a large scale, or when you want to talk about, you know, scalability, or how do I put it on a server, everybody runs away. So this is exactly a classical thing that you would see in the industry. Because you know what? The ops guy is usually the guy that stays most awake when things go down, right? Because it will go down. I mean, I'm not saying that I'm not a fan of positive engineering. I am, but you know, sometimes you have to prepare for negative engineering too, right? Things would go down. People would, you know, you don't want to be the guy that, you know, is literally in charge of this. So that's why everybody's hiding, right? So moving on. Because why is everyone hiding? Why is this supposed to be fun? This is supposed to be what you want to do. But see why? This is literally how everyone looks at you if you're the guy tasked with operationalizing the machine learning model. And I bet this picture speaks it speaks volumes because, you know, these guys, the pallbearers, the famous Ghanaians that, you know, do the dance when things go super wrong, right? So you should know that if anything goes wrong, you're dead. Like you're dead because when the thing is not in production, it's okay. There's no harm, right? It's fine. No users, nothing you don't know. But I mean, I'm not saying that all errors in production usually are like the problem of DevOps, right? Or MLOps, right? No, I'm just saying that most of the time when a server goes down, maybe you didn't benchmark for 1 million users. Classical example would be, let's assume that you have just deployed a model or you build a model that does a proper recommendation for a service like Netflix. So I log in based on what I see in my interest. You just tell me, oh, I think you would love to see Avengers, or I think you would love to see movie X or movie Y. Now you're doing all of these things with recommendation engines. Fine, it was working, but it probably didn't think about scaling, right? And then all of a sudden, it gets to the point where you have like 1 million persons needing a recommendation. Okay, 2 million. Okay, 300 million. And it's not fast. There's low throughput, no more recommendations. Systems fall through because it will fall through. It sometimes always falls through. Trust me. Like it's not. This is not about being prayerful or being hopeful. It's they're machines, and if things don't go right, they fall through. And most times you don't know because you never expected that 300 million persons are going to be hitting your service at a particular time. So get ready for the pallbearers. I'm not saying you're going to die, but I'm just saying that you're going to almost likely carry the blame, right? So let's move on. So now let's do a little bit of a recap about data science lifecycle. I'm talking about this because there is usually the part that is very, very ignored. You know, first of all, when you come into a company and you have to have the business understanding, right? Oh, what do you do? We are a company that we do delivery, and we need a machine learning engineer to be able to build us a service to predict where we're going to be able to focus on delivery for today, because based on our past events, good stuff, you've understood the business, right? Exactly. Now you move on to data acquisition. You can go any route you want. I mean, this is, maybe the data is ready. So for instance, if you go to data acquisition and understanding, you're going to probably look at what type of data. So the point of this slide is that we talk about, I'm going to spend a little bit of time here. We want to talk about the importance of remembering how data science lifecycle works. This is usually like a de facto stuff because most of the time you find out that this is how it's going to work. There is always going to be data and there's always going to be a source. There's a step missing here. Apparently I got this image from the towards data science. There's a step not here. For instance, data source, pipelines, environments, wrangling and exploration and cleaning. Most of the time, there is another skill required to be able to make a very good transition, from here to here. See, data acquisition is a very big business. I mean, most of the time, especially the tricky thing is if you come from the angle that, data is ready. So most of your analysis you did on Kaggle or Zindi or driven data, or maybe it's always like almost near clean, right? Then you've gotten this data. So, they've even put the data in the CSV form, but I can tell you that most of the time, the data is not like that. Like I from experience, I have never been in a company where I join and I have all the data I want in CSV for me to do my stuff, right? Most of the time you spend like a shit ton of time sourcing for data and trying to fix a thing or two, So now in between this place or around this place is a very vital role played by a data engineer. Now I can tell you that this is a very, very interesting thing, and I want to use this opportunity to tell anybody listening to me and seeing this is that your data engineering skills is as important as your data analytical skills. Why is that? Data does not play nice. Data doesn't ever play nice. Like you'd see data working right today, and then tomorrow is entirely not working the way you want it. Data does not care. Data can decide to break. There could just be an annoying line break somewhere and the whole data is messed up. Or you have a character that is very, very not, you didn't account for that edge case. There's a chance that the data you want is in an image. There's a chance that the data you want is stocked up in an API or in a database. So you can just come and you see, a classical scenario would be okay, you just joined us. We want to solve problem XYZ, but we don't have the data for problem XYZ. We're not saying that you're going to solve it in 1 month, but what it means is that data acquisition, everything, you're going to be the one to take care of it, arranging it, making it ready for you to be able to use in machine learning or whatever you want to do. Now, I want to also highlight something very important, right? It is at this point of data ingestion and processing that people kind of like introduce data bias. Now, I don't want to talk about data bias which is one of the things that you have to put into consideration in the ethics of machine learning. Now, what is data bias? Data bias is literally structuring data in a way, like in a very layman term, in a way that your data is almost always tilted towards favoring or not favoring a particular scenario. I mean, there was a classical case where, most of the models that were used in China to train for a particular camera was a webcam was targeting a particular set of people. And it was a big problem because someone else uses that and it's okay, but you use it and it's not okay. So data is not even balanced. I think data bias comes from unbalanced data, and it's one thing that you should be wary of. You might be thinking that what you're doing is working, but when you try to put it on the broader scale, it doesn't scale. So now you have acquired the data, and then you move straight to modeling. This is usually the most interesting part for most machine learning engineers, because it's where you pull out your mathematical skills. I also want to point out that around here, for you to excel properly, that you need a very good software engineering skills. Trust me. Most of the times you see people, I think I want to kick back, at things like Python for machine learning or Python for data science. There is nothing like Python for data science. I mean, I understand what the people are trying to convey, but I also want to, tell everybody out there that there is nothing really like Python for data science and then Python for geographical science or Python for, the concept of that, it tells someone that if you get to a particular point, this is all you probably need to be a data scientist, right? Or this is what you're going to need. But no, that's not even true, because there are extra skills. There are weird skills to have. There are weird tools to know. There are you need to be able to, for you to be able to write good code that scales, you're not going to limit yourself at stopping at least comprehensions. You can't, you shouldn't. So now, what does that mean? It means that I'm just trying to remind you that why it's important that your software engineering skills is top notch. I mean, if you are literally thinking that you can hack it with just stopping at understanding how list works, and because you think you can be able to slice data with pandas and that's all you need, someday your pandas probably won't be able to read your code, or probably be able to give you the fastest throughput that you need. Maybe what if you want to be able to write a code that runs as fast as possible? Most people then, they would say, oh, why do I need to learn algorithms and data structures as a data scientist or a data engineer? I'm going to tell you why. See, most times when you read a code written by someone that is not really experienced, you see a lot of for-loops and for-loops and for-loops. I mean, it's interesting when you see that, because it's working. Because the most important thing, if you go by, I think Ken Beck's principle of development, make it work first and then make it faster. Usually, data scientists are stuck at the make it work first part. Most times, you don't know how to make it work faster. And why do you not know how to make it work faster? It almost does not matter to you, because it's solving your problem. It's local in your computer. It's okay. It's just you. You are the only user. But then next thing you think about it, you are supposed to have 10,000 users, 100,000 users. Then it starts mattering. So you see, then you don't know how to make it work faster. You don't even know what's wrong with that. You probably haven't even heard about the big annotation, or probably how to numerical analysis of computer speed or the computer algorithms, or how analysis of a computer program. So now the next thing is, moving on, you're going to talk about modeling. Think about you're probably going to be this awesome guy with the green bulb and with all the ideas. Now modeling. So you got into modeling, you've done your feature engineering, model training and model evaluation, AUC, RMAC, you've done all these smart things, you've talked about the back prop. Now, I'm trying to represent everything like deep learning and machine learning and NLP and everything under this thing, because they all probably go through the same thing, feature engineering, clean data. Oh wow, I don't think this is too much. You say, okay, you know what? Let's do clustering, and then you say, okay, you know what? Let's do a dimensionality reduction method. Let's apply a k-means cluster. I mean, you know the cool stuff, right? Let's know what's not needed. Let's throw the others away. Then you talk about model training. You talk about, oh, now this is an ensemble. Let's use the bagging method. Let's use the cables. All the sweet stuff. So a lot of assumption I'm having right now is that, you already understand how to go through this. This is what you do. You are a rock star here because you've been doing this. And I mean, I am not I'm talking to beginners, but I'm talking to beginners in the concept of MLOps. So this is you. You're having super fun, right? Then let's talk about deployment. Deployment, everybody goes back to this. So I need to say that because sometimes I have been there before. Most people that come into data science didn't come into data science from the core. Excuse me? They didn't come to data science from the core computer science or computer science or computer engineering background. Most people come from quant, economics, and where you probably have to worry about servers and all of that. So now deployment, everybody, because at the end, everything is concerned. You talk about scoring performance. You got to score performance of the model online. You got to score you're going to monitor it for failures. You're going to probably deploy it to a web service or an intelligent application, or create an API or a mobile app. A lot of things now come into play. Now, you see, the problem is the end part is red because it's the scariest part. Does the customer really accept what you build? Now, let me explain. The customer could be your fellow engineers. They can be like, oh man, this is crap. We can't use this, right? So this is it. Or it could be the end user. Maybe the end user has paid you for a service to be able to predict something. Maybe they predict who their next love is going to be, or what's going to be the sex of your baby the next baby you're going to have, and then you've done a wrong job. They don't like it because, well, maybe it works on your computer, but it's not working on their mobile device. It goes down every 3 hours. So this is it. This is why I'm bringing this up, is that the point of concern is this deployment, and we're talking in regards of machine learning. So why is going to production scary? It actually shouldn't be. This quote is made in 2020 in the year of coronavirus, because I think that after this year, moving on, just the way people have Anno Domini and the year of the Lord and all of that, we're going to have the year of coronavirus. I mean, just like the year of the Spanish flu, and all of that. So, I mean, we're going to, can never forget this 2020. I hope we don't, because we can take proper precautions. Yeah. I wanted to highlight this because this is usually, I'm not saying that it's not okay to be just the guy that does the analytics or that builds the model. But I'm trying to tell you what is sometimes most obtainable in every way of being. Sometimes the company is not large enough to have someone that is dedicated to DevOps. That's why software engineering, they have a concept called code owner. If you're a code owner, it means that you get to build and you get to deploy, right? But you you find out that most of the companies you might probably work with, they don't have such structure. Maybe you might be the only data scientist or data engineer or machine learning guy and a deep learning engineer. You know how to work locally. Everything works, and so you don't have a problem with that. So literally, so what do? So this is like a roadmap. This is gotten from Simply Learn. I'm not saying this is a very good infographic. I love it. First of all, you get a hands-on experience with programming languages, Python, R, or Java. You master mathematical concepts to grasp the input and implement machine learning algorithms quickly. Learn engineering skills. Very good. I mean, they highlighted something very important to me. These engineering skills to clean, process, manipulate, and work with data. And then you master machine learning algorithms. Now you see, you gotta, most of the times, honestly, some of the algorithms, you don't build them, right? You already use them out of the box, to predict. Then big data. You start working with Spark, and you want to understand and analyze what is being stored, processed, and everything. And then you move on to business intelligence. You can communicate your data, you can make meaningful visualizations, you can tell us, what, tomorrow is gonna rain. I mean, I asked a question, what's missing? All these things can be done on a single computer that, there's no end user being considered here. Now, you become a machine learning. See, if someone follows through with this plan, you're going to become a machine learning engineer, but something is missing, which is you probably have never put anything in production. And it's okay. It's entirely okay. But it's not also okay if you're going to be in an industry that expects that you have to do that. So, so if you see, if you ask what is missing, we're talking about what's missing. We don't have ops skills, DevOps skills. You don't know anything about servers. You probably haven't talked about monitoring. You don't even know why you gotta use Flask. You probably haven't heard of any other way to deploy your models. You probably don't worry about that. You probably don't even, if someone says, how do you plan to put this model in a mobile app? It becomes big, and you're gonna look like, wow, that is something I've never even thought about. Like, I don't know if anybody tried to use PyTorch sometime 2 years ago. There wasn't so much stuff about deployment. So you start doing things like converting PyTorch to, ONNX, and then convert it into a tensor model that you can put on your mobile device. So it was a long trail of things to do, but things are becoming so easy that you can just, build the model on PyTorch. It's a model that takes inputs and gives you outputs, right? So you think about it from the engineering concept. Oh, it's a model. So it's like a data structure. It's actually like a data structure that looks at the data and then gives an output. So that means you can put it in an API. So the next question, what's an API? Or how do I host an API? So it becomes like a spiral nature of questions that you're going to keep asking yourself. So ops, DevOps, what are they? Let's talk about it. Ooh. I usually always like to bring this up because this is exactly when people say DevOps or MLOps, and you keep saying, what are the tools for MLOps? Is it different from DevOps? What changes? What's the, But now look at this. This is gotten from our Slack. And they try to depict all the tools that you sometimes use productionizing stuff and making sure that it works. Now, see, ops is not just about putting on a server. It involves planning, building, continuous integration, continuous feedback, operate, deploy. These things are the things that makes up ops. In DevOps, now, I know that most of developers, data scientists, ML engineers, we are all here. Most of us. you build. But the funny thing is that, we in building, we don't even consider building for operationalization, because when we think about building, the only thing that comes to your mind is your Jupyter notebooks and the library you want to consume. But that's not it. Look at this. I'm gonna like bring this more down, but you see things like Docker. Why is Docker important? Okay, Kubernetes, GitHub, GitLab. Then you talk about how to plan, Office, continuous integration. The ones I've used, Travis CI, Circle CI. Then you talk about deploy. It could be on Azure, GCP, AWS. Then look at this, operate, Sentry. Zabbix, all of that. Continuous feedback, Intercom, Selenium. Sometimes, okay, no, Selenium is on the build. I mean, you Cucumber, Jasmine, browser stack, Zoho CRM. Let's keep going. Now, I want to talk about from DevOps to MLOps. So this is gotten from a talk from Sasha Rosenbaum. I think she's a senior program manager at supposed to put the name under here, at Microsoft. And MLOps is ML plus dev plus ops. So the developing part is what I want to stress on. So what is the development normally for an introductory data, a beginner data machine learning engineer? What do? Algorithm training plus testing. You put it on ETL, data pipelines, and all of that. But, this is normal. But is it a part of continuous integration and deployment? Those parts you usually never have to worry about them, and especially the fact that the data science communities that we have most times don't stress on these parts. And that data science is usually like a new thing. I can talk like it's not a super old thing like in Nigeria. So people don't talk about DevOps, Kubernetes so much in machine learning and all of that. I mean, you gotta be somewhere that is needed, someone Docker, and you talk about Jenkins or Ansible. Why do you need Ansible? I'm just gonna take time to run through those tools and what they can do for you. I'm gonna literally gloss over them, and so that anytime you have, you can see the beauty of them, because that's not really what I wanted to do. Now, operate, you talk about continuous delivery. Why is continuous delivery important? Why is continuous integration and continuous deployment important? Now, imagine that there's no continuous integration and continuous deployment pipeline. So you've built the model, and you've found that you want to change this model. Something is wrong, it's not working. And then you figure out that, oh shit, for me to change this model, I cannot continuously integrate. I have to bring it down. I have to tear my code apart. Or you don't even know how. Now, model inference and monitoring and management. People keep, we've seen this monitoring like a lot of time now. So what is monitoring? You need to know when things go wrong, because things will go wrong. Like, it's very important that you understand that in machine learning, you shouldn't just be thinking about the fact that your Boston house pricing set or data set is working, or you can just, do your feet or train test splits and, you get your data back, and that is no. That's not it. You run the predict class or predict method and on the data, and then it's working, and then you're like, this is it. No, that is not it, right? That's not all it is, right? That is not all there is to the game. At the end, if you ask yourself a question, imagine that you're in a company and then you're the only one working there, and then you build the model. So what happens? The model is useless to the company you're working for if it stays on your computer. But you've done work. You've built the model, but it's in your computer. It's not somewhere. We want to have this model running on mobile, on web, hardwares, on refrigerators, and anything you want to put it in, but it's not working. You don't even know how to go about it. Like sometimes know that there's a limit to what you can do as a data scientist or machine learning engineer. But I'm not saying that you should now become a super nerd that you can now bring a hardware and then write all the C programs to fix it. That's not what I'm talking about. But this is trying to highlight the importance of thinking about production when you're trying to build, and telling you that what I want to do is to be able to spike your interest, to know that there are things like this, and you have to understand that you got to start learning them. The same way you picked up or you learned machine learning engineering, maybe you went to a college to study it, or maybe you went to postgraduate schools to study it, or maybe you just learned them right off the bat, or internet taught, right? Sasha Rosenbaum, this is a very good diagram, and I want to be able to talk about two things here, right? This is you, data scientist. This is someone else, an app developer. And there's collaboration here. I want to say something very important. You depend on the kind of team that you join. Maybe most times there is a software team or software engineering team. They've built their app, but you were asked to incorporate a model or anything or do data science or in any form, right? And of course, you guys have to work together. This brings me to GitHub. I mean, I think that Git is one of the best things that happened to the world, because the concept of being able to be at your home and collaborate with someone elsewhere, and you can ask them, you not really ask them, you can just collaborate with thousands of developers. Your code can, live in multiple repositories. And you know that Git is so interesting because it makes working together very important. I mean, why is Git important? In fact, it's the first thing that I've seen that data scientists don't use, especially budding data scientists. Why someone usually asks me, why should I use GitHub? I mean, you think that because you write your code in Jupyter Notebooks makes it safe? It doesn't make it safe. It doesn't even make it reusable. It doesn't even make it, how do you track changes? How do you, if the project was large, how would you track it? How would you make continuous improvement to this project? How do you want me to work with you on this project? How do you want to, if you want to go overboard and use stuff like the GitHub actions or actions, right? Or being able to seamlessly improve your workflow. What if the project grows? I mean, there's like a lot you can do with GitHub, and most of the time, GitHub supports, even as much as storing, all your code bases, your code dependencies. You see, most people don't know that. I don't know if anybody knows how tough, maybe at the point where you're starting off, how terrible it is for you to set up your working machine as a machine learning engineer, maybe your workspace and all of that. You can literally just write your script, set up script and put it on GitHub. You'll store your Visual Studio Code or your PyCharm or your, checkpoints and everything the way you want it. I put it on GitHub. Whenever you get a new computer, you just clone and you run, and then bam, you're like ready in 5 minutes. You should try that. So now, what is the flow here? Model reproducibility, check. You've built an app. This model reproducibility is something that you have to do locally, right? Like, you're trying to talk about the fact that you have satisfied all the statistical importance of this model. I mean, sometimes you go off and then you want to build a product, and sometimes you build the model for the first time. I mean, I've seen, there's usually that fear. What if the model does not work? Yeah. So you have to be sure that anybody can reproduce this model and, get almost the same, result. Train a model, you've built an app. Good. So you embed it, train a model, you validate a model, you deploy a model, which is release an app, right? So you talk about monitoring. You monitor model, you monitor management and monitoring, you retrain model. So you see the iteration. I also want to point out that with MLOps, there is iterative development. You send your model to a server, it doesn't work as expected, you make a change, you retrain. There's a flow. Imagine how else would you do it? Maybe you put it on someone that you can't even integrate with. I mean, it's living there. It's an old model. You can't even change it. You can't make improvements. You find out that you're stuck. So one of the things that MLOps does is that it makes it possible that you can literally just monitor, analyze performance, go back, make changes until you get finally to improvement. Now, I wanted to bring this out because this is usually this side, most people are around here. This is what you find software engineers doing. They work with Docker, they work with Amazon AWS, they work with Puppet, they work with GCP. They know about deployment, they can write code and all of that. Though I don't really agree with that the narrative of a machine learning engineer is someone that can do data science and still deploy the model, but anybody could do it. The point here is that you would see that this was separated on the basis of what is obtainable most of the time. You'd find people, machine learning engineers that are very comfortable with just building the models and have someone else worry about the deployment. So that's basically why this is very, very important to me, that you just see that, there's a disparity I think this is a disparity in thinking process of how majority of people work right now. Now, question, data scientists, quick iteration, versioning, reuse, great tools, ease of management, unlimited scale, and limiting drift. Now, DevOps, quick iteration, versioning, reuse, compliance, observability, uptime, updates. You see, when you merge these two skills together, you get something super formidable. This is ideally how things should be. So it might be different people, it might be one person, but it's something to know that there is something like this, and projects can fail if they are not considered. So this is it. This is like two stretch work, cases. Wow. Okay, moving too fast. We're almost gonna be at the end of my slide because I didn't try to keep this like super long. These are like two flows. I am not in any way trying to promote Microsoft Azure. I don't want to. I'm not saying that is the best for. You can actually build a custom operationalization for you, but I want to mention something. Now, you see, this is classical of how things can. Most of you have used the Azure Machine Learning Studio. I can tell you that at a point in my life, it was one of the things that made machine learning easy for me. Because I didn't worry about productionizing my model. They had to worry about that. I didn't have to worry about something else. They had to worry about that. So for me, for instance, now look at this. Let's talk about a proper DevOps system. Now look at this. There's a trigger. I want to explain what these things can mean, and you can design your structure anyhow you want it, but this is one of them. You see, so you can say if there's a trigger, maybe data-driven trigger, maybe you've written a pipeline that tells you whenever data comes into your system. Let me know. If maybe schedule-driven, for instance, a classical example, you find that companies usually run cron jobs at the end of the week. So cron jobs are like background tasks, maybe query all the databases in the production system and store it. It could be every minute. It could be anytime you want it. So it's usually like metrics driven or anything you want. Maybe if metrics fall apart, so usually you need a trigger. Most of the time, we're talking about the ops part now of machine learning. Why is it important that you need a trigger? What if you set a trigger that every single time that you you know, that some maybe your model accuracy or precision falls below something, let me know. This is a very big trigger for me. So this trigger is going to help you to run super good iterations. So you can go to your Azure machine learning pipeline endpoint. This is a very, very big thing to say, because what is an endpoint, really? Like, so an endpoint, literally, it's where the data flow happens, right? I mean, for instance, you must have, where you served your model could be an endpoint for a lot of things. It could be where that people have to send your image and the image for you to analyze it for them. It could be where people have to send you the texts to classify them. So it could be anything, right? So, you know, what happens, you know, maybe there's a new data. So you say, okay, great, we have new data. It's like, I want to put this trigger, like what happens in your head. So this is not complex. I'm going to walk you through it. So there's a new data. Every Saturday, you are tasked with getting on a new data that is passed into the system. You know, maybe you don't have to, you have to, you can automate these things, right? The data comes in, what do? It comes in, you take the new data, you ingest it. So you see, you go to your endpoint, your Azure machine learning retraining pipeline. What does this pipeline do? So what is the pipeline doing? The pipeline is like, yo, whenever data comes, train a model, evaluate model, register model. All of these tasks, I can bet you, happen to a lot of production level systems. Train model, evaluate model, register model. It doesn't have to, it's not something that you maybe that has to stop. No, it just happens seamlessly, right? So you just see AML model management. Now I'm talking about this framework because it's something that I have used. Like, and I have used it in the past, and I have, maybe not now, but I have used it, and it's literally helped me to understand how to even go about a custom pipeline of choice, right? Or build mine, you know? So now what happens is that, what do? You see, look at this, guys, look at this. I don't want to talk about this, you know? This is just you know, this is the first thing that you do when you want to deploy the pipeline. So this is where probably maybe it could be anything, right? Look at what happens here. So there's a new code. This is where your code is, right? This is it. This is you. This is entirely what you've done. This is maybe probably you want to, your code base where you've written you want to do some tests, you want to check for data sanity, whatever. This is it. And then you run this code, but this is one-time run. This is always one-time run, right? You know, for instance, you create a working space, which is, you know, is a term you find on Azure Machine Learning Studio. I'm not trying to use this term to explain and say this is how it's going to be, right? I'm trying to think about it from the angle of concept of what happens, because your structure might be different. It might be that you don't even have a test. All you do is that every single time data comes in, do so, check the model, deploy, remove the old one, you know, whatever. It could be that if something goes wrong, send me an email. But if it's weekend, please don't send me an email. If it's when I'm on holidays, please don't send me an email. But if it's Monday to Friday within work hours, please send me an email. If something goes wrong, let me know. If it completes, let me know. If the model is failing, let me know. So like literally more about how do you incorporate like iterative software development processes into like machine learning. Now you create machine learning workspace, you create machine learning compute, you publish. This is the pipeline you've published. And this is a very interesting part I want to talk about. You've registered the model, you've trained, you've evaluated. So all these things here, this is like block of operations that you can run. Now, you come in here, Azure Machine Learning, you package model into image. I'm going to tell you, see, packaging model into image is just a term for you to be able to do. Maybe there's a way, for instance, one of your process might be that you want to pickle your model. I mean, I'm sure most of you have heard of pickling. You want to pickle your model. You don't want to. You want to be able to, or you want to be able to store it a particular way or anything. So, I mean, this is just a term that is a good practice, because image snapshots can help you do a lot of rollbacks, right? So say this, you're staging. This staging, or they call QAs, what they call quality assurance. I wish I could tell you how I do it internally, but look at this. You deploy a model as a web service on, maybe like this is an Azure container. Please guys, I keep saying this because every time I see like an internal Azure terms, I'm not promoting Azure, I'm not promoting Microsoft stuff, but I'm just telling you that this diagrammatically can explain how you'd want to do your own thing. First of all, you might, you know what, let's talk about how you probably want to do yours. You cannot not do without a repository like GitHub, right? So you probably, if you don't know how to use GitHub, I think it's time that you learn how to use GitHub, right? So you push a code to GitHub. You probably have an action, GitHub actions that you've written that you can, maybe you've hooked it to something like, or, build systems and all of that, like for continuous integration and CI/CDs like Travis CI or Seco CI. You've done all of that. You've checked for code completions. You've run your tests. You've made sure that you met your standard. Great stuff. What do? You say, okay, you know what? We're using an Amazon Web instance. We've already created, we've already known that if this happens, this instance is already running. So what we do, we come in with, we check for new data. You check for new data comes into database, send me a trigger. It comes into your trigger, you're an Amazon Web instance, what do? You start training. Because what your trigger is that you want to turn whenever any data comes in. So I'm just arbitrarily telling you that, because it's very unfair to literally just come and tell you, this is how to do it. This is exactly how to build a data MLOps system. The requirements, the tools, the practice can differ based on where you are or your company. So, I'm spending time looking at this to tell you that this is usually boring when you are thinking about it and when you have not done it yet. But it's usually very interesting when you've done it. So you deploy, now you're going to ask, they put it on a container instance, they put it on a Kubernetes instance for scalability, or for, having it in pods. And then guess what? This process can keep running all over and all over and all over and all over again. Now, let's look at something else. This is something you can see in H2O.ai. So what happens here? I think this is pretty simple. There's an end user here. There's you. So you've trained your model with what? With the Amazon SageMaker. You're good. Everything is dope. Then, of course, this talks to the H2O.ai serverless client, driverless, and then what do? This is automated machine learning. Most of the times, all these area is handled by H2O.ai, but I'm trying to talk about the architecture of what they do. Feature engineering, time series, NLP, blah, blah, blah. Then what do? You pass it to a Lambda function. What does a Lambda function do? It's serverless, the device. So what happens here is that there's an abstraction between, what happens to the end devices and what happens to like the beginning devices. I know they're considering the fact that this demographic of people probably going to listen to this is, maybe beginners, and most of the things here would be off. But you know what? I mean, there's no better way to say it. I mean, there's no better way to start telling you that these things are like very important. I mean, these are the things that you have to start worrying about. I mean, and if you take it step by step and try to eat it off in bits, you find out that at some point you're going to be able to understand how the full architecture works. Now, so why is MLOps important? Why is all this jibby jabber about MLOps? Why is it a thing? Because change is the only constant in life. I mean, if you look behind, I kind of like covered Sasha's DevOps with MLOps, right? And shit happens. Shit happens, something might fail. If you're not watching it, it will fail. If you weren't watching it, it will fail. And I'm gonna tell you something, right? This might not be your job. You might be 5-10 years into your career as a data engineer, data scientist, a machine learning engineer, and you might have never have to productionize a machine learning model. But it also has a huge chance to be your job, because you might join a very small company and and you're the only one. Or maybe because of your experience, you even have more experience working in the computer ecosystem than the new software engineers. Maybe it's a startup, maybe it's your own startup, and you probably cannot afford to pay someone to productionize. I'm not saying that you're probably going to do it 100% like a professional that's done it for years, but you got to understand that shit happens. Because the model works locally on your computer does not mean that it's production ready. There are other things in production: culture, when to check, monitoring, performance metrics. How do you log for errors? How do you check for error? So the reason that I'm throwing all these things out there is that don't get comfortable, because find out that there's a funny saying that things people do. They'll say, in machine learning community, they'll say, when is that model going to leave your Jupyter notebook? I don't know, you probably must have heard of that before. You've built models, but they are usually on your Jupyter notebook. That brings me back to this. You see, Django, let me talk about if you take a very good look, you find out that all the things here, there are something that, like, if you are into a Python or an R community or ecosystem, find out that if you take a time to look at all these tools and what they do, I think that's one of the things that I do. I take time to, what is Elastic? Why do I study all the tools and see what they do? And first thing is to be able to understand, oh wow, Django web framework, I can actually build an API and have it. There was a very, very funny way I built a model once. So I had the model live in my Google Drive, and I had the Google Drive, direct URL to my Google Drive where the model lives. So, I have to always call the model. So what I did is that I want to use the model. So the model is stored there. So I'm using Google Drive as like my storage for the model, because models sometimes can be very heavy, 256 megabytes sometimes. So you put it there. So you want to use it. So what happens is that you maybe your Jupyter notebook, you go there, you call it, you download it, or maybe somewhere you pass your data, you make predictions, but it wasn't scalable, right? So you find out that, oh, maybe I could scale this thing. So this is with Django. What if I build it somewhere in a way that my model is living maybe in a cloud instance or Docker? Maybe I'm going to use Django to always pass requests from users to my model. Like, the options are limitless, right? And I want to bring you up to something. There are other things. So deploy. You could say things like, I'm sure people must have heard about, the AWS SageMaker, GCP. See, Microsoft and Google and AWS has made life so easy that you could roll out something in a short time, because the infrastructure has been taken care of. And of course, it's worth mentioning that there are things known as infrastructure as code, where you deploy your full infrastructure and it is as code, and you have all these compute giants manage a lot of your problems. So this brings me entirely to reference this again. It's your first month as an entry-level ML engineer, and you just started rocking your job. Jupyter notebooks, scikit-learn, TensorFlow, pandas. Then it's time to put the model into production. I'm sure you understand why this happens now. The tools are a lot. There are so many things to learn. It requires a lot of machine software engineering skills. It requires a lot of being meticulous, checking for servers, monitoring, things that you would not naturally want to do in data science, right? And this guy that walks into a room is exactly the kind of guy you dread, because he always brings the bad news. He always tells you it's time to do these things, right? And what do? Everybody starts hiding and everybody starts disappearing. I'm sure you understand why this is probably going to happen, why you're probably going to die, because now the end users are concerned. Whenever a server fails or something goes down, you know, someone has to bear the blame. I mean, it's never going to be the computers, right? So, I mean, I tried so much to use this pictorial representation to, you know, highlight, you know, it's a huge topic. It's not something you can literally like pick up in one day, but you know, I'm trying to, the whole aim is that when you know, as you're listening to this, you'd have thought about a different angle of what you probably should learn, or a skill you should pick up. For people that are in web development that are very conversant with how to put a machine learning model in production, some of the things here wouldn't be new to them, right? Because it's a part of development that is tied, is mostly to software engineering than it's to data science. But I'm telling you that it's a skill that it doesn't really have to be just in software engineering. It's something that you also need as a, you know, as a data scientist, as a machine learning engineer. And of course, not to stress it very much, is also the importance of knowing how to manipulate data. Data engineering is also very important, because, I mean, if in fact there is no MLOps, there is no data science without data engineering. If data is still scattered in an API, a CSV, or you have to scrape it, what are you going to do? It's still stuck. So that being said, brings me to a very, very, very short conversation on MLOps and why it's a good thing that the community around here start, I'm sorry about the plane, start thinking about it like really often, and you know, and put much thought in it. And as an individual engineer, why it's also a concern that you should think about it and you should adopt these skills. It might even be for your pet project. I'm going to tell you something very tricky for people that probably haven't had industrial experience. See, look, there's data scientist A and data scientist B, or there's a machine learning engineer A, machine learning engineer B. Both have never worked in an industry before. Machine learning engineer A did a project, Boston house pricing data set, blah, blah, blah. But went to the next level, put it in production. It's working. You can even go to a mobile app, go to a particular link, test it, and it's working. This guy did something super amazing. He built a model to tell traffic when to board a bus and when not to. So I'm trying to hire both of them, and I have to make a decision. I mean, no matter how trivial for me that Boston house pricing data set was, even if the person picked up the deployment stuff online and read it and implemented it from a blog or anything and was able to achieve it and it works, I'd still hire them. The bias is always going to be there over someone that could predict when not to board a bus or not, but the model is still local, live on their computer. Why? Because the other guy has figured out that the most important thing, aside from making sure that the model is reproducible and it follows standards and it's not biased and all the AI ethics I mentioned, is that he has figured out how to take it to the end user. And whatever you are doing in machine learning and the end user is not involved, you've done nothing. Apart from if you're not a research scientist. Even the research scientists want to get it to the end user. Even the mathematician is doing all this work so that you get a context from it. So sometimes I know some knowledge is for you, but most of the time, it's for the end user, and you always have to have the end user in mind. You always have to have the end user in mind. So with that being said, brings me to the last slide I have. Please stay home. Please stay safe. Stop COVID-19. Wash your hands. So thank you. If you have any questions, you can drop it. And I am right here. I'm gonna be like on the chat to tackle questions, and you could always find me most anywhere on the internet with a cyber droid man, and I'm always willing to talk more about this, and maybe if I'm around you, I can show you how it works in real life. Great. Thank you. Bye-bye.
Yeah. All right. Thank you, Stephen, for that amazing session. I really, of course, learned a lot, and I enjoyed the session with you. And I'm so glad we did this, to be very frank, because I was able to pick out a lot of good practices and knowledge from you, from how the tools to use in production to how it's really done in the industry pretty much. And I'm very, very excited we had the session. So thank you, viewers. You've made it to the end of the session. Congratulations for picking up best practices and good methodologies, or whatever key points you took out from this session. So if you're willing to get to hear me and Steve talk about production, ML projects in production, A/B testing, the need for A/B testing, and all of these things, you can check back on our YouTube channel tomorrow. Yeah, tomorrow evening, same time tomorrow evening, we would have released a session I had with him, with Steven, and you can watch that and enjoy the session. It's just going to be about a few minutes of your time. So once again, go back and make sure you engage with the community. Check the description for a lot of other resources and materials that you can use. And I think we'll catch you next time. So same time next. Of course, we still have another session next week. So follow our YouTube channel, subscribe to our YouTube channel, turn on notification. Of course, follow us on Twitter for more updates, and join the community if you can. All right, so we've come to this end of this. Thank you for attending. If you have any questions on the PML course, reach out to us on Twitter, tag us, and we'll be able to respond. And the credits for this, of course, icons and everything. All right, take care, guys. Have a goodbye and stay safe. Yeah.